but to not belabor the point, yeah, we have a bunch of slides, so I'm gonna share screen. And slides are here. Cool. So cool, today is descriptive statistics and data visualization. And it's kind of like two intertwined things, right? Because all of the statistics that you can compute, like there's a way to visualize them, right? Like we saw in class, it's like the mean, right? You can plot you can plot the frequency of different numbers, and then you can look at where, like, if it's nicely formatted data, right? If it's nicely like behaved data, you can look at where like the hump in the visualization is. Oh, you can't hear me? Okay. Let me check my settings real quick just to make sure. Okay. Yeah, no, it looks like it's just my normal microphone. Test. Okay, yeah. The test came through. So, okay, cool. Thanks. I don't know, Georgia, maybe, hopefully, like, I don't know, maybe you can restart your computer. I don't know. Sorry. But yeah, the visualization is like sprinkled. Okay, cool. Resolved. Throughout, because yeah, so for like the point is like you make these plots of data, right? You make these data visualizations, and then you can read like the meaning of like these descriptive statistics that we're learning kind of comes out from the plot, you know? We'll see what I mean, but yeah. So real quick, where we left off was we loaded this data set of gifts to universities from foreign entities, public and private, and we did like loading, and we looked at how to, like, we talked about the structure, like, you know, a row is an observation and a column is a property of that unit or observation. There's like a cat here, and I'm trying to multitask. And like at the end of the slides that I didn't go through because they were kind of detailed. I guess where we ended was like I extracted just the NYU observations from the data frame. So if you want to like learn how that works, you can go back to the video from last week. But this week I'm just gonna look at all of the observations, like not just the NYU ones, just because the NYU ones are it's kind of a smaller sample, you know? So what I'm doing here is, well, I loaded it just like we know we have to import pandas first, and then we use pd.readcsv. And then what I'm doing here is like, how do I put it? I couldn't think of a good way to like pedagogically say this other than all that's happening here is I'm trying to, so if we look at I should have put yeah. So if we look at, forget about the code for right now, but if we look at the table, you see the foreign gift amount, it isn't you can tell it's not, Pandas isn't recognizing it as a number because there's like a $sign in it, right? And there's commas in it. And so long story short, all this code is just, here I tried to say, okay, well, I'll replace $signs with nothing, and I'll replace commas with nothing, right? Meaning I'll just remove the $signs and I'll remove the commas. The replace function in pandas is a little weird. Like you have to call .str first. So you extract the column like we talked about last time, right? We say gift df, and then we use the square brackets, which means I want to extract this column that I specify inside the square brackets. And then for like normal, you know, math operations and statistics operations, like you just call dot and then the name of the function. But for string operations, it's a little bit weirder just because you have to tell Python like, oh, I want to use string functions on it, not like math functions, right? Because remember, string is like a totally separate data type from numeric data, like int and float. So you just have to do .str, and then everything after the .str, like pandas will recognize like, oh, they're trying to work with this column using string functions, not numeric functions, right? So that's what's going on there. So it's just str.replace. The $, and then you could do this in multiple lines. I just kind of did this so it would fit on the slide well. Like you could do like, you know, replace the $, in one line, replace the comma in another line, and then this .as type, that's a conversion function. So you do .as type, and then you put the type that you want it to be in, right? And we want float because dollars are decimal numbers, right? So, oh, and this like try exception stuff, also don't worry about it. It's literally just because the error that pandas produces was too big and it didn't fit on the slide. So this just basically takes the end of the error message. Like all this code, just you don't need to learn it. I just put it so that we could see the end of the error message, right? And the end of the error message says, could not convert this string to float, right? And it's in parentheses. Well, it's this, like, this is the value that it's saying it is having trouble converting, right? And yeah, I think for people who know like finance stuff, accounting, I was like a business minor and I don't know why, but I learned all this stuff, like accounting stuff. But anyway, the parentheses just mean like it's a credit, right? Meaning that the university gave money to the entity. Or I guess really what it would be is like maybe like a refund or something, you know? Anyway, the parentheses just usually means like negative in a financial balance sheet. But pandas doesn't know that, right? Like we know that because we're humans and we can do semantic interpretations, but to pandas, right, it's like, no, to parentheses, that's not a digit. I don't know how to convert that, right? The only like special character that it could convert is like the dot, because it knows that's a decimal point. But it doesn't know what these parentheses mean. So anyway, I just made an even longer, more disgusting, like chain of commands here, I guess. And the point being that now we have, we have foreign gift amount, but we saw that it was a string, and we could use the dtypes function, right? We could use the dtypes function to see that it's a string. But now, if you look at this command, right, you might notice something, which is that I didn't include the .as type float. And that's just because I wanted to show you like how it can be misleading. Because you might think, oh, look, like I got rid of the parentheses, I got rid of the $, I got rid of the commas. I must have like cleaned it, and now pandas will see it as a number, right? And it looks like it. It looks like, oh, this is a float, right? This is a float. They're all numeric. There's no weird characters. So I must have made it a number, right? But the reason I say it like that is because you always want to use the dtypes property. It's not a function, which is kind of weird, right? Notice there's no parentheses after dtypes. And we can see that actually it still thinks that they're all strings, right? Even amount cleaned, that's the variable we just made. Object is, long story short, like the pandas code for a string. Object just means like it could be anything, but it's like the default, meaning it's kind of just like a generic data type. It's saying like, oh, you can put anything in this column. You could put a numeric, you could put int, a float, a date, like all these types of variables as if it's object, right? The ones that are ints up here, the ID numbers, like those you can't put a string in them, right? You can only put ints in them. But any of these object ones, you could just, like you can make a new row and you could put it in it, or you could put a string in it, whatever. So that's not what we want, because pandas is gonna, like if we want to do these data visualizations and we want to compute statistics and stuff, it's gonna need to be like a numeric type. Pandas is gonna need to know that it can, like, add up all the numbers and divide them by n or something to get the mean. So we use the types to see that, oh, I see, I didn't do that. I didn't convert it to a float yet, right? And so now I just take the column, right, giftdf, square brackets, amount underscore cleaned, and I kind of assign it. It's like a little bit weird to look at this at first because you're taking a column, right? So this is the thing where you have to read right to left when there are assignment statements because Python will execute it right to left. So we have to look at this and we have to see, okay, it's taking giftdf, it's taking out the amount cleaned column that I already made in the last slide. And then it is running the as type, the conversion function, into float. And then it's assigning it back into amount cleaned, right? So that's why it's like, kind of, you can think of it like this is the old version of amount cleaned. And then we're saying do this to it, and then put it back, make that the new version of the amount cleaned column, right? So I just wanted to, because it can be a little weird at first to see an equal sign and it's like the same variable on either side, but that's what's happening. It's saying take the old version, perform this operation on it, and put it back, right? Store it as the new version. Cool. And now we use D types and we see, great, it has parsed, I guess that's the word for it, to like parse the strings as a float. It has parsed, meaning it has converted the strings into floats, right? So cool. That means we're ready to do variable statistics, data science on it. And that's where like we kind of shift gears, right? Because it might have been confusing like on homework 2, for example, because these things here are data types, right? Like these things are how Python is storing the number kind of internally, or not just the number, how Python is storing the variable internally. But then there are like conceptual, there's like the conceptual side of the coin, which is how we understand as like humans, like our interpretation of the variable, right? So as we see in this like common data types row, like an int, if you see that it's an int, you actually don't know, you know, it could be a discrete numeric variable, or it could be an ordinal categorical variable, right? So that's like an example of where it's no longer like up to Python to store that information. It's up to us to like know it, right? Meaning, like if we see a column and we see that it has like 1, 2, and 3 in it, like 1, 1, 2, 1, 3, 1, 1, 1, 3. We see that in a column. We have to know like, is that like a measurement of something where this row has 1 of them, this row has 2 of them, this row has 3 of them, or is it a categorical variable, right? Where it's actually just saying like, oh, 1 is a code for like the first category, 2 is a code for the second category, and so on, right? So yeah, I just wanted to distinguish it. That's why in like in class, it was very explicitly mentioned that it's different from data types, right? Variable types. So yeah, numeric, this ordering here is not arbitrary. It's kind of from, I would say like left to right. It's kind of from like most mathy in terms of like how you learn math, like in calculus and high school and stuff, to least mathy, right? Because a continuous variable is what we have in calculus, right? It's a real number. They're not only infinitely many, but they're uncountably infinitely many. It's just like, when you think of this, you should think of like your calculus, like all the graphs and stuff from your calculus class, right? Where like the lines are like, there's like a plot and there's not dots on the plot, right? Like in calculus, there's no discrete dots, right? It's just a continuous like plot, like X, Y axis. So that's kind of a continuous variable, right? You can think of like, temperature, right? Like between any 2 temperatures, there's like a third one. If you measure it more and more and more precisely, you could think of it like, well, I guess everything's tricky now because we have like the like quantum mechanics on the Planck length. So I was gonna say like time, but I think there technically is a smallest unit of time. I don't know, physics people might correct me, but I think it's like the Planck length is like 1 divided by the Planck length is the, anyway. Just very things where like you aren't going to be able to count the number of values that there can be, right? Like you can't count like how many possible temperatures are there. You wouldn't really be able to count it because I'd say like, oh, hey, in between 2 of those that you counted, there's a third one, right? All right. And then discrete is, you can think of a plot with dots, right? There's a visual in the lecture slides just showing like continuous plots versus discrete plots that I think is helpful. But I didn't include it for time, but yeah, discrete is like, you know, think natural numbers or integers, right? So like in the field, like is the math term or group or field, whatever you want to call it, in the set of integers, like there's no integer between 3 and 4, right? So that means it's like countable. Like you can actually sit and count them. And I can't come along and be like, aha, between the last 2 that you said, there's a third one. No, you can like count them in order. And then categorical, that is less about like measuring things, like going with a ruler or a thermometer and measuring things. Categorical is like humans taking a measurement but putting it in like a category, like a finite number of categories, right? So these 2 are infinite, in this case continuous is infinite and you can't even count how many things there are. Discrete is infinite but you can count, meaning, sorry, I shouldn't get into math stuff, but yeah, just these are like infinite and there's a finite number, right? Meaning there's a finite number of categories because humans like to create schemas where it's like category 1, category 2, category 3, right? It would be kind of weird if we came up with if we were categorizing dogs or something, and we were like, that's a Labrador, that's a golden retriever. Like there's a finite number of categories. It would be kind of weird if we were just like, there's an infinite number because like who is sitting there writing them all down, right? Because we live a finite amount of time. It's weird to think about, but yeah. Ordinal would mean like that there's an actual, the order like 1, 2, 3, 4, like that ordering actually makes sense. Like the numbers have a meaning like in ordinal, you can think of like low income, middle income, and high income, right? Like maybe an ordinal variable could be like income level. And then the value 1 could mean low income, 2 could mean middle income, 3 could mean high income, right? And so it's ordinal because like 1, 2, 3 there makes sense. Like something is increasing as the number of the category is increasing, right? There's an order to it. Like it would be really confusing if you said it like 2 is low income, 1 is high income, and 3 is like middle or whatever is left, right? Middle. Whereas nominal is not that. Nominal is where like you've just totally gotten rid of even like the order property of numbers and you're just assigning codes to them, right? So like the dog example, that would be nominal. And maybe int is kind of important because a lot of like old data sets, like back in the day, they didn't have ways of storing strings. If you go way back to when I was talking about like how strings are just stored as numbers in a computer, like back in the day, when they had to store things on big like servers, they would just put numbers. So it would be like 1 is the code for Argentina, 2 is the code for Angola, 3 is the, if it was like a survey of countries. So I actually, in social science, personally encounter ints for nominal variables a lot, but yeah, that just means like they've assigned a code to strings, right? Whereas in this case, in this data set, you can see a bunch of things where they're not using codes, right? So like here it just writes out Thunderbird School of Global Management or Arizona State University. They don't put like 1 is Thunderbird, 2 is Arizona State. So that's a case where it is a nominal categorical variable, but there's no numbers at all. So it's a string. So now let's go through the data set. Hopefully we get it because we talked about it a little last week. It's just each row is a gift. You have the country of giftor, meaning where the money came from, and then you have the institution that it was given to, and the date, and the amount. So let's look at these variables and see what we think the data types are. So give me 1 second for that. So I have an old cat and he, I don't know, he throws up a lot. It's fine. So the gift amount, right? Here we just do like the most basic, well, one of the most basic pandas commands or operations that we learned, which is just doing the square brackets and saying, I want to extract just this column. So we extract the amount cleaned column and it just shows us, by default, it just shows you like the first 5 and the last 5, right? With little dots in the middle to show you that there's a bunch of stuff in between. But that's just so we can look at what these values look like, right? And it's literally just taking, is just isolating this column of the full data set. And so I meant to make it so that it would like reveal the answer, but it just shows the answer at the bottom, right? Which is that the amount cleaned, it's a numeric continuous variable. And this is actually like the trickiest one in the whole data set because it's like, why not discrete, right? It would seem like you can count the number of dollar amounts, right? But then I sat and I thought about it, and you can think about it as well, which is that because of the weirdness of like global financial accounting, again, like what I learned in my like random, completely rudimentary like business minor thing is like, actually in finance, you can have very small fractions of money, right? Meaning like when we use like currency, we just have dollars and cents or pounds and whatever, like it's a finite number of splits. But in financial transactions, it can actually be like, you can send someone like 3.17526841138 dollars, right? Because like a lot of stuff is investments, and then you say like, oh, I'm getting a return of like 3.785% on the investment, and you're like multiplying dollar amounts. And yeah, I won't like rant about it, but the point is that that's why I picked numeric continuous rather than discrete, just because like these are gifts on the order of like tens of millions of dollars sometimes, and so you can imagine that they would come from like, you know, say like interest payments on an investment. If it was restricted that they had to be like dollar amounts, and in this case it's a little bit weird because they do all round to 0, but I think they might be rounded in this case. But you know, the point is they might not be rounded, I don't know, but the point is like dollar amounts in general can be thought of as a continuous variable, unless you know that like it's going to be in like maximum 2 digits, right? Then it's in a way discrete. So next up, I was trying to think, okay, so that's a numeric continuous variable, and then do we have any like numeric discrete variables in this data set? The answer is like, not really. I mean, you have the year of the gift, but that's a sort of its own weird thing. Like a year is like I think it's called like an indexical variable, and I don't want to worry about that. So instead, I just made a variable called hold on, there's a chat. I can't go over the midterm. I've been given my instructions that I have to go over this stuff. So yeah, midterm questions can go on Piazza or email. Cool. And like if you want to leave because that's fine, I understand that. Cool. So I was like, okay, what's a discrete variable that we could come up with? And came up with the very dumb one, but one that is discrete nonetheless, which is institution length. It's just the number of letters in the institution name, right? So Thunderbird School of Global Management, 39 letters. Arizona State University, 24 letters. And now suddenly we have a numeric discrete variable, right? Because you can't, it wouldn't make sense to subdivide these below like integers, meaning there's no institution that has like 39.3864 letters, right? A letter is a discrete unit and you just count them, right? So that's a numeric discrete variable. Going to what I mentioned earlier, the name of the institution, that's a categorical nominal variable because like there's no natural ordering. I mean, I guess you could do alphabetical ordering, but there's no like, oh, Arizona State University is one more than Thunderbird School of Global Management. It doesn't really make sense to talk about it like that, right? Like, there wouldn't, if I said like, hey, how would you like order Holt International Business School versus California Institute of Advanced Management? Like, you wouldn't naturally think of a order like, oh, this is 3 greater than this one, right? So that's why it's nominal and not ordinal. Whereas then I was like, okay, do we have any ordinal variables in this data set? We don't a priori, but I made just like ranking, right? That's all this code is doing. It's computing the rank of the gift amount, right? So meaning like this first gift from the Instituto Tecnológico y de Estudio to Thunderbird School of Global Management, it's the 1,139th largest gift, right? This from Saudi Basic Industries Corporation to Thunderbird School of Global Management is 528th largest gift, right? So now if we make this variable, now the order actually does make sense. Like if I tell you, oh, actually the way you should order these is by like the biggest rank, the biggest rank should come first, the second biggest rank should come second, biggest gift should go first, the second biggest gift should go second, the third biggest gift should go third. Suddenly you have an ordinal variable, right? And we can see that especially when we sort by the gift rank. So we can see like, oh, this is the largest gift of the whole thing, right? From Qatar to Carnegie Mellon University. They're actually like all Carnegie Mellon University. Like I think the top like 20 are Carnegie Mellon, which is like very weird. I don't know what's going on with that, but anyway, Bermuda is giving hundreds and hundreds of millions of dollars to Carnegie Mellon. Who knows? But that's a categorical ordinal variable, right? Because now 2 means like, oh, that there's an actual like ordering. It's not like I just arbitrarily assign one row to have gift rank 1, another to have gift rank 2, right? They're not random assignments. They're actually like meaningful, meaning you know that 2 is going to be a lower gift amount than 1, 3 is going to be a lower gift amount than 2, and so on. So that's the order. All right. Measures of frequency. So now that like we know the types of variables, now we can say like, okay, well, different types of variables, there have different descriptive statistics that we can compute about them, right? In the case of categorical variables, the most interesting like first thing to measure is frequency, right? Which is just how many times does each category appear, right? So in this case, I can take institution name and I can call dot value counts. We learned that in lectures, like in the example code for week 9. And here I'm just taking the top 10 just to make it slightly cleaner. So it doesn't have the dot, dot, dot and stuff because there's just gonna be a bunch that are tied for last with one gift. But I was just interested in the top 10, right? So what this is saying is this is a measure of frequency, right? It's the frequency of how much this value right here appears in the column, right? 3,206 times. So that's a measure of frequency. It's just the frequency. But you can transform it, right? We learned this in the example code from lecture as well by calling value counts, but with the argument normalize equals true. And that computes it from that transforms it from an actual count. Like here there were exactly 3,206 gifts to UCLA, and we can transform it. So now we have a percentage, right? Now we can say, oh, UCLA, 17.44% of the gifts were to UCLA, right? So actually, usually like this is actually a little more helpful. But yeah, the point is you have like frequency, and then you have proportion, right? That's what it's called when you have a normalized frequency. It's the proportion of all the observations that have this value in institution name, right? Cool. And we can do the same thing, country of giftor, right? That's just another categorical nominal variable. Unless you can think of a good way to order the countries, they're just arbitrary. Meaning you can just set like one is, like I said, in these old school data sets, it's usually like one is Argentina, two is Aruba or something. They just say one is the first one alphabetically, two is the second one alphabetically, but they just assign them randomly. Meaning like there's no real mathematical reason why Argentina would have to be one and Aruba would have to be two. You could just say Argentina's 50 and Aruba's 65 if you wanted. Cool. And we get the counts and we see England is the one that gave the most gifts. And again, we can convert to proportions, and we see, oh, that means 13%. 13.54% of the gifts were given from England. So cool. Once we have that, we can say, well, let me put it this way. So the frequency or the normalized frequency, meaning the proportion, those are the descriptive statistics that are like most obvious for categorical variables. But now if we move back to the numeric variables, we use basically the describe function like PropJR talked about. I can't remember if it's, yeah, I think it's PropJR. Talked about how like the describe function gives a ton of like meaningful, interesting descriptive statistics for numeric variables, right? So we see here, we call .describe, and it gives us a bunch of things: the count, mean, standard deviation, the minimum value, 25th percentile, 50th percentile, which is the median, 75th percentile, and then the max. The thing here is that this is like a learning opportunity, because even though I like just have been in these weird science academies since I was like 12, I still just can't, my brain can't really process scientific notation. I don't know about you all, maybe, but I just can never, I always had to convert it, like take out a piece of paper and convert it. So I read this and I'm like, I'm not good at figuring these out. Pretty much the only one I can immediately interpret is that the minimum is 0. So for some reason there was a gift of $0 recorded. Who knows why? And it's a learning opportunity, because then I just wanted to show you, like I just Googled pandas describe format, and the first thing that came up was a Stack Overflow post, right? And I opened it and it's like, yeah, it's the person is having the same issue as we're having. But they're like, I don't know what any of this stuff is. And someone just said, hey, cool, you can do this, right? And we see that it's like, let me make it a little bigger. They're doing .describe like we did, but they're adding this additional thing here that looks messy. You don't have to worry about it, right? That's the beauty of Stack Overflow, is you can just try it, right? So I just did that. I just put that command at the end of .describe, and bam, we don't have scientific notation anymore, right? We have, what's it called? Digit base 10 notation. And now I can like read off what these mean, right? Meaning now I can say, oh, okay, so this means the average gift amount was $501,400.67 approximately. And yeah, the minimum gift was $0. The biggest gift was $7.7 million. And so on the median gift amount is 60,000. Yeah, raised hand. What's up, George?
So you just mentioned like how you went to Stack Overflow for that describe thing. I was wondering on the midterm would we be able to like do something like that? or is it just notes only?
It's a good question. The midterm format changes all the time, meaning like just every time I TA it, it seems to be different. So I'm going to bring up the syllabus and see if it says anything about it. Let me grab that real quick. Syllabus. Here it is. Yeah, I'm guessing it's not. Yeah, it's not screen shared. Let me new share. Cool, here's the syllabus. If it doesn't, I don't know if it'll say something. Midterms. If it doesn't say, basically, you're gonna have to post that question on Piazza because there is a very weird hierarchy in the TAs. If you haven't been able to tell from all the things I've been ranting about, complaining about, where, yeah, I can't know, like I can say what it was like in prior semesters, but I don't know this semester. Yeah, it's up to Prof. JR and Sperling, the policies on the midterm. I kind of just, I just grade them at the end. Sorry, I feel like bad because usually I'd be like, oh yeah, it's like this, but I just don't. If I say something, I get yelled at because they're like, that's wrong. So I'm just gonna say you gotta put that on Piazza. But it's a good question. I would find it out. I would post it.
Yeah, thanks.
Yeah, no, word. Cool. So Stack Overflow. It really, but like the answer to your question is that like it should be open internet. It should be. I hope it is because no one, no one's like sitting there doing data science in like a cave with no Wi-Fi or anything. Like it doesn't make sense. Like we got this data set off the internet, so we should probably be able to also go on the internet and like search Google and stuff, right? I don't really understand. I had a bunch of CS classes that didn't allow. Actually, like I think most CS classes, when like in my like undergrad and grad school, didn't. Anyway, you get it. So I went on there and yeah, we get this command that we don't need to understand. I mean, it's okay. I understand it. Like if you want me to explain it, whatever, but you don't need to. We just copied it. And it tells us, yeah, max, min, median gift is 60,000, blah, blah, blah. And then we do our first visualization, right? I'm almost done, but it's our first visualization where we use matplotlib.pyplot as PLT, right? That's like kind of the, you don't have to memorize it, like because you don't have to memorize anything, but you'll just see it a lot, right? That this is like the canonical way to import matplotlib, and we do plt.hist, and we give it a column that we want it to plot, right? The weird thing is like a lot of people will write like plt.hist and then just put amount cleaned, right? But that's the problem is that matplotlib doesn't know which data set you're using if you do that, right? So you have to like explicitly first like think of this like what's happening. The way that Python is executing this is it's first running what's inside the parentheses, right? And it's saying, okay, they want to extract the amount cleaned column from the gift.df. And then it's evaluating the outside. It's saying, okay, so I've extracted that column and now plt.hist just takes like numbers. It doesn't know where they came from, right? This is kind of weird. Matplotlib like doesn't talk to pandas, you know, like you have to use pandas commands to just get the data out as numbers, right? And then you pass the numbers to PLT, to Matplotlib. And then, yeah, another thing that you should keep in mind with this like Matplotlib stuff is that it's very like pedantic. So maybe you really don't have to worry about it, but it's kind of important for stuff in the future, data science, which is that when you call plt.hist here, like if you just ran this without the plt.show line that I put after it, it will show the histogram, but that is because of a quirk of Jupyter, where Jupyter is like doing like error correcting. It's like, oh, they didn't call plt.show, but they made a plot, so I'm just going to show it, right? But really, like, because remember, like, Jupyter is not the only place you can run Python. Like, you can also just write text. You could write Python in a text file and run it and just not use Jupyter at all, right? And in that case, like, plt.show is the correct way to show the plot that you just made, right? Meaning this constructs a plot, it doesn't show it yet, and this shows it. So that's why I'm always going to put that, and you should too. It's kind of like how, like, in fact, it's exactly like how you should really put print when you want to display like a number or something. When you want to display meaning like you have to put print when you want to display something, even though Jupyter will auto display the last line. It's similar here. Like, you should use plt.show to show the plot that you made, even though if you just ended with this, Jupyter would like figure out what you're doing and show the plot, but it's not like the correct way to do it. Cool. But we see this and it's like not that helpful because we just see like there's almost every gift is between 0 and 1,000. I can't do scientific notation at all, but they're all very small. They're mostly small. And then there are like a very, very small number of humongous gifts is what this is showing us. Hist has an optional bins argument, which we can do, and it gives us a little bit more information. We can see like a tiny bit more, but even still, like there's almost every gift is bunched down near 0, right? We can see there's like some that are, you know, I don't know, maybe like 100. But that's just the bins argument to matplotlib, and then thankfully, like we're almost done because the next few slides are just a thing I did to because I wanted to show you, even though you're not responsible for this. This is not like required or anything. So I'm not going to explain the code, but I just transformed it by taking the logarithm, right, of every gift amount. And it turns out that like if you have a plot like this where it's very, very, very skewed and you like can't see really what's going on, you can take the log and then you can say, oh, okay, if I plot the logs, I get a nice graph because of how logs work. It like logs take skewed distributions and kind of unskew them is the long story short of it. And we can say like, oh wait, there's a spike at like 12.5 here. Or sorry, after 12.5. It's like about 13.125 is my guess, and it's kind of absurdly close to the mean, right? So we say like, okay, there's a spike at where the log is like 13.125. And since it's a log, we can undo that, right? The inverse of the log is the exponential function. So here I'm just using NumPy to take the exponential function of my guess for this spike, 13.125, and I get 501,320. And if we go back to when we called .describe, it's like really close to the mean, right? So the mean is 501,400, and this like guess from what this spike was is 501,320. So, you know, you can use log plots, and like as humans, I think it's a lot easier for us to like see the mean will be somewhere around here. Cool. Beware, because yeah, descriptive statistics don't tell you about the spread, right? They just tell you that like this is the center of the function. We saw that in class. Also beware, this is new, not from class, I think. Maybe, yeah, I think. Which is Anscombe's quartet, which is these 4 data sets that this guy Anscombe created one time, and they look just hilariously different, and yet they have the same mean and the same standard deviation, right? So yeah, this is like my favorite example of all time of why like these descriptive statistics, like you still need to plot them, right? When we plot them, we can see like, oh, these are probably not the same type of data. Like these are not, we should not think of these 4 variables as displaying the same pattern. And yet if we just looked at the mean and we just looked at the standard deviation, we'd say these are the exact same pattern, right? So you gotta be careful. So that was mean is the center, standard deviation and variance are the way that you find out how spread out things are. Now variance is just the average square distance from the mean, right? Meaning a variance and standard deviation, this whole like concept, it just says like, okay, so fix the mean, right? Or like compute the mean. And now let's say like, that tells you like the center of the data, but now we want to see how spread out things are from that mean, right? Is everything like concentrated right near the mean, like, you know, a spike, or are they really spread out? And the way we do that is we just compute the distance of the points from the mean. So like in this case, like the mean would be somewhere around here. So these points would have a big distance from the mean. These points would have like a small distance from the mean, right? And yet we don't average the distance from the mean. We actually average the square distance from the mean, which seems confusing at first, but you can just do a little like mental exercise of like, why do we square it? Which is like, here, look at this data set I made, right? The mean is here is 0 because it's just 1, 2, 3, -1, -2, -3. Right, so the mean of this is 0, and if we take the standard deviation, we see like, oh, there's some spread, which is true. There's spread away from 0, right? But if we just took the average distance from the mean, which is what I'm doing here, we would get 0, right? Because here the distance is 1, but here it's canceled out because the distance is -1. Here the distance from the mean is 2, but here the distance from the mean is -2, right? So each of these cancels it out, and that's why you don't, that's why you need to square it or take the absolute value. That's a separate thing. But yeah, in case you were wondering why variance is the average squared distance from the mean, not just the average distance from the mean, right? Yeah, you got to be careful. That's how you'll look if you just take the average distance from the mean, because you'll be like, it says there's no spread from the mean, but there is. That's you. And why do we have both standard deviation and variance? This is the last slide. Is because the variance, it's the average squared distance from the mean, but when we start squaring things, we lose the units, right? If you square a temperature, it's no longer a temperature. Like if I took the temperature and squared it, it's not Fahrenheit anymore, right? Or Celsius, whatever. It's nothing. It's a unitless quantity, is like what they say in physics, chemistry, bio. So like here, the standard deviation of the gift is in a unit. It's $2.76 million. It retains the unit of the variable that we're working with. Whereas the variance doesn't have a unit. Variance here is approximately 7.6 trillion what? And then it's the end, but I love this.
We did an intranet search for ice cream. We come back with 6,121 results. We did an intranet search for the gloves. How much results did we get? 325, 0, 113. So you times those together, what does you get? This is just people on the internet looking in. 203 zillion, whatever, 496,400, and then a 1.
Right, that's what you're gonna sound like. Talking about the variance of amount cleaned, right? You're gonna be like, this number doesn't have units. So cool, that's all. Have a good weekend. I'm sorry I couldn't talk about the midterm, but I will talk about the midterm in office hours and on Piazza and etc.